Normal distribution. The graph of a normal distribution has the bell-shaped curve with one peak. The mean mu is located in the center of the graph, straight down from the peak. We can go to the right 1 standard deviation, 2 standard deviations, 3 standard deviations, and to the left 1 standard deviation, 2 standard deviations, 3 standard deviations. The empirical rules or the standard deviation rule or the 68, 95, 99.7% rule states that if we are within 1 standard deviation away from the mean, then we would cover an area of 68% of the distribution. If we were to be within 2 standard deviations away from the center, from the mean, then we would cover 95% of the distribution. And if we are within 3 standard deviations away from the mean, then we would cover up to 99.7% of the distributions. Therefore, we can find the area, or in most cases, the probability of each of these pieces. With the empirical rule or the 68, 95, 99.7% rule, we can find the probability that a certain value is 1 or 2 or 3 standard deviations above the means or below the means. Now, if the value is not precisely 1, 2, or 3 standard deviations away from the mean, then we can standardize this using the formula z equals x minus mu over sigma. Once we found the z value, which is known as the z-score, we can use a normal table z to look up for the corresponding probability or percentage. Suppose a continuous random variable x is normally distributed with the mean mu and the standard deviation sigma. Given any value x, we can always find how many standard deviations away from the mean the x value is by calculating the z-score. Z is x minus mu divided by sigma. Because of this, regardless of what kind of normal distribution it is, we can always standardize the values in the random variable x and convert them into the z-score. Once we have the z-score, we can find the probability. So it is not necessarily that this x value have to be 1, 2, or 3 standard deviations away from the mean. For example, suppose an exam score is normally distributed with the mean of 75 and the standard deviation of 5. Now, we were told that this is normally distributed, so we're going to draw a normal bell-shaped curve. Label 1 standard deviation to the right of the mean, 2 standard deviations away, 3 standard deviations away, and to the left as well. This is 70, this is 65, and 60. These are 1, 2, 3 standard deviation to the right, 1, 2, 3 standard deviation to the left from the center, which is where the mean is located. Now, according to the 68, 95, and 99% rule, we know that there are 68% of students scores between 70 and 80. We know that there are 95% of the students scores between 65 and 85, and there are 99.7% of the students who score between 60 and 90. But What happens if we want to find the percentage of student who scores over 82? Notice that 82 is not precisely 1, 2, or 3 standard deviations away from the mean. So we're going to standardize this. X minus mu over sigma will give us the z-score. The z-score tells us how many standard deviations away from the center this x value is. X is 82, mu is 75, sigma is 5. 82 minus 75 is 7. 7 over 5 is 1.4. What we just did is that we standardize this into a standard normal distribution where the mean is 0 and the standard deviation is 1. With the score of 82, we know that this score is 1.4 standard deviations away from the mean. It is positive, meaning that this score is above the mean or on the right-hand side of the mean. If we were to end up with a negative z-score, that means the x value is on the left-hand side or below the average or the mean. We now use this z-score 1.4 to find the percentage. Notice that we're looking for the percentage of students who score above or over 82. That means we are looking for the percentage on the right hand side of the z-score. So we shade it on the right hand side of 82, or z equals 1.4. This is a typical normal table. The normal table consists of the negative z-scores and positive z-scores, and usually a normal table accompanies a graph with a disclaimer. In this case, it says that the table entry for z is the area under the normal curve to the left of z only. What that means is that this is the table for the standard normal distribution where the mean is 0 and the standard deviation is 1, and it only gives us the area on the left hand side of any z-score. The z-score in the problem that we just did, we found that the z-score is 1.4. From the table, the z-score is read from the first column and the first row. The z-score is usually consists of 2 decimal places. Notice that the first column gives us the first decimal and the first row gives us the second decimal. For example, if the z-score is minus 3.1, then this is minus 3.10. We would go to the first column to get minus 3.1, and we would go to the first row to get the 100th place, which is 0. And so the area on the left hand side of minus 3.1 is 0.0010. If the z-score is minus 3.15, then we would go to the first column to get minus 3.1 first, and we're going to go to the first row to get the 100th place. The first column is minus 3.1. It gives us the 10th place, and the first row gives us the 100th place, which is 0.05. Together with the first column and the first row, we obtained the 4 decimal digits. This is the area on the left-hand side of the z-score, minus 3.15. Remember, the table only gives us the area on the left-hand side of the z-score. In the previous problem, our z-score is 1.4, so we have to go to the positive side of the table z equals 1.4. And also, remember, the z-score from the table is 2 decimal place. So even though our z-score is 1.4, we're going to rewrite this at 1.40. What that means is that we go to the first column, which is 1.4, and the 100 places 0, which means we go to the first row. Thus, the area on the left-hand side of the z-score 1.4, it only gives us the area on the left-hand side of the z-score. The area on the left-hand side of the z-score from the table is 0.9192. But this is not the answer because earlier we shaded on the right-hand side of the z-score 1.4. We label 0.9192 on the left-hand side because the table only gives us the area on the left-hand side of the z-score. But that's fine. If we're looking for the area on the right-hand side of 1.4, we just simply take 1 minus 0.9192, which is 0.0808. Thus, there are 8.08% of the student who scores over 82.